So in this last video, we're going to tackle the very last page, which is going to help us see what a paired t-test is going to look like. All right, in this question, is the express lane faster? So these AP Stat students decided to investigate which lane was faster in the supermarket, the regular express. To collect their data, they randomly selected 15 times during a week, went into the same store and bought the same item. One of the students used the express lane and the other used the closest regular lane. To decide which lane they would use, they flipped a coin. They entered the lanes at the same time, paid with the same method, and recorded the time in seconds it took them to complete the transaction. So it looks like two distinct separate groups, but they're paired. They're paired by the time. They use the same item, same payment method, and same time. Okay? So the state step, my parameter is going to be mu sub d, and I'm going to go to the answer key because you're going to see how you have to express this. Mu difference, or mu sub d, it's the true mean of differences of transaction time, regular minus express. You have to explicitly state which way you're doing the subtraction. You could have done it express minus regular. You have options here. So the null hypothesis is that this mean difference is 0. And the alternative is that the mean difference is greater than 0. If I'm doing regular minus express, I would assume that it would take longer in the regular line. And they want to know, is the express lane faster? So that should take less time. Okay, and my significance level that I'm going to use is 5%. For the plan, now, earlier in the lesson, I said with the one sample t-test, you're not going to see any of this. Now that you have a paired t-test, it could be paired data from an experiment. Most likely it's going to be. Doesn't have to be. So you're going to need to see, okay, am I dealing with an experiment, yes or no? So here I have a random sample of 15 times. And I'm actually disagreeing what I have here. Is this an experiment? They're not randomly assigning going to a regular lane or an express lane. So no, this is a mistake on my part. The 10% condition is needed. I would say 15 times is less than 10% of all times you could go to the regular line or the express line. Normal large sample, we run into an issue here. Sample size is not large enough. We don't know the shape of the population distribution. So here's what you need to do. And you'll notice I put this up at the top here. You're going to take the regular time, plug that into a list. I plug that into list 1. Express time, plug that into list 2. The way I set this up was regular minus express. So then in list 3, I need to create a whole new list. So I'm just going to put in some data here. This is not the correct data. So say I have 45, 80, okay. And then in this one, it doesn't help if you don't actually put numbers in that make sense. So let me try this again. Okay. So you have your data in list 1 and list 2. Then you're going to go up to list 3, hit enter. And I'm defining this as list 1, second 1, minus second 2. My regular minus my express. Or I could do L2 minus L1, whatever. And that's going to give me these differences. You'll notice some will be positive, some will be negative. This is not the data from the question. I'm just showing you a brief example. All right, so back to the problem at hand. You'll notice I put the first couple differences in here just so you could see what was going to populate into list 3 for me. So then I needed to get a box plot of the differences. So I would go to my second y equals, I'd turn my plot on, I'd pick the correct box plot, but I need to make sure, for me, I'm looking at a box plot of list 3. I have a line, I got all sorts of graphs going here, but I'm just looking at the box plot of the differences. You'll notice this doesn't have any whiskers because there was only 3 data points. But then again, I'd hit trace and I'd get my 5-number summary. That's where this is going to come from. I was kind of running out of room here to get to 200 on my paper, so hence that. So you'll notice what I said. The sample size is 15, which is not greater than or equal to 30. Box plot shows no strong skewness or outliers. So our sampling distribution is approximately normal. You want to label it. You want to be precise. Be specific to the point. Conditions met, do a paired t-test. This is no longer a one sample t-test. We have paired data with degrees of freedom equal to 14. Your summary statistics, we went over that in the last question. Let's go over it again. You're going to have to go to stat calculate one variable statistics, but now you're going to need to choose list 3 because you need the mean of the differences and the standard deviation of the differences. So the mean and sample standard deviation of the differences, that's where this information came from. Remember, what was in my calculator is not all of this data. So this is the sample mean difference. Usually I'll put a subscript of diff and then S diff. You don't have to. So the statistic minus the parameter, we're claiming that there was no difference, divided by the standard error, gives me a test statistic of 1.97. So my sampling distribution. For these questions, 99% of the time, we're going to claim that there's no difference between the two. P-value, to get that, I'm doing TCDF from 1.97 to infinity with 14 degrees of freedom. I don't need to double the area because this is not a two-tailed test. Because the p-value 0.035 is less than alpha equals 0.05, we reject the null. We do have convincing evidence that, and then I'm just going to strip this context, that the true mean difference of transaction time regular minus express is greater than 0, which makes sense. So the express line does look like it is quicker. So there's a lot more little details that go into a paired t-test versus a one sample t-test. Be very mindful of them. And in most instances, you're probably going to have to create a box plot and get your summary statistics from the calculator. So hopefully this was a meaningful lesson and made sense. We will pick up here next week and move on to two sample t-tests and intervals.